everyone. So now we are going to see an important topic. It is going to be on metapopulation. Seriously, this is a very important topic where several questions like rescue effect, very commonly asked questions do come from this topic. So please listen this till the end such that you will get a complete ideology on this metapopulation. Okay, so already we know what is a population. What is a population? Population is nothing but it is a group of individuals of the same species which live in a particular area. That is what is called as population. Now one more prefix is added. It is called as metapopulation. So what is this metapopulation? This metapopulation, it is a group of population, absolutely, because the word population comes now. So it is the group of population of the same species, that is all correct, but it is spatially separated. That means it is all having a spatial location. For example, you all study in the same school, but do you all live in the same school or college or university? But do you all live in the same place? No. Few may live in the hostel, few may live in the house which is nearby, few may live in a house that is far by. Your spatial arrangement is different, right? So this is a spatial arrangement of the population, but they are going to interact with each other. Can you find any difference in the arrows? Yes. So one is the source. Source is where it begins. Sink is where it ends. Only one type of arrow have used or two types of arrow have used? Can you see properly? Check it. Everybody in this class should check. I have used two different types of arrows, isn't it? So one arrow, it is showing only one-sided one. And other arrow is showing two-sided one. So is it something significant in this diagram or simply I have put this? It is of significance. That is why I have mentioned it here. So what is the significance of this arrow? Okay, it is only going to help in the rescue effect. What is the rescue? Sometimes you forgot to bring something. Maybe your professor has asked you to bring some samples, or maybe it is a paper, or maybe it is a pen. Early we used to have this inks being refilled. So if you miss to bring the ink, your friend will put a drop of ink on the table such that you can take it up. Now I think ink fountain pen you are not using, but still you may have something which needs the help of your friend. So your friend is going to rescue it from your problem. Same thing happens here in this metapopulation. So how this rescue happens? So whether it can be a one-way or it can be two-way. Okay, right. So rescue can happen. I help you, you help me. So that is between us. Okay, so it may be within us. I help you, you help him, you help her. So that is within. So two key terms are there. One is going to be between, okay, and one more is going to be within. With that only we are going to see the types of metapopulation. Okay, right. So it is operated at two levels, as I said. One, it is the local scale. In local scale, how is the arrow? How is the arrow? It is pointing only one side. It is not two side here. It is making out only one side. So in local scale, the individuals, they can move within the population. Within means it is one side. See, this is helping this, this is helping this, this is helping this. This is patch number one. This fellow is helping these all. This fellow is helping this. This is getting help from all these three. Got it? Because it is having less number, no. So like this fellow needs 100 rupees. Okay, so this fellow gives like 30 rupees. This fellow gives 20 rupees. This fellow gives 50 rupees. So totally he is getting 100. This is what is rescue effect. If it is taking place from everybody, it is taking help from everybody, it is a local scale. Okay, so it is within the patches, it is getting the help. Understood? So this is what is the metapopulation of this local scale, and it is getting help from all the members, or within the patch it is getting the help. Okay, and majorly the birth and the death is coming under this category. Okay, so birth and the death do come under this local scale. Now we are moving to the second one. It is called as the regional scale. So how are the arrows? All the arrows are two side. I help you, you help me, right? It is like two side. So it is actually between the patches. Your parents help you, you help your parents. right? So that is what is between. So this is done by dispersion and colonization. Okay, so two types we have seen in metapopulation. One, it is the local, and other one, it is going to be the regional. What is the keyword in the local? What is the keyword in the local? I told you that this occurs within. Okay, one-sided, within. Okay, this is occurring between, two-sided. And what is the good example that takes place? Birth and the death. Okay, right. For between, it is going to be the colonization, or it may disperse outside. It is the dispersion. Either the colonization or dispersion. So this is going to be the regional scale and local scale. So three major points as of now. Number one, we learned what is going to be the metapopulation. Metapopulation means nothing. It is a population. Population means similar species in a particular area, but it is going to interact with each other in a specific patch. So that is what is called as metapopulation. It is of two types as of now we have studied. One is the interaction that takes place at the local scale. So local scale means it is going to take place within. Okay, so that is no, it is taking help from everybody. That is within, and then it is going to mainly influenced by the birth as well as the death. And second one we saw is the regional. So it is a two-way interaction. So that is happening between the patches, and it is done mainly by dispersion and colonization. So seriously guys, all these terms are getting tricked, but please don't get tricked, and remember that all these points are exam point of view very, very important. So whenever you are studying something, no, don't just like that read and go. It may not retain. Okay. So if you feel that some topics are very, very difficult, or you may find it very hard to remember, please take notes. See that in your own handwriting, you will have a better memory, and then close your eyes and try to recollect. So now we have studied three slides. What is metapopulation? What is local? What is regional? So all those things you try to recollect. If you are recollecting, yes, you are a very good study material. Okay, fine guys. So don't worry, come on. Let's make up a move towards the next one. So now we are going to see the typical types of my metapopulation. Okay, all right. So what are the types of this metapopulation? Number one, it is the classical Lewin metapopulation, mainland island metapopulation, patchy population, and then non-equilibrium population. So what are the four types of this population, especially with the spatially dynamic moving persons? Classical Lewis metapopulation, mainland and island population, patchy population, and non-equilibrium population. These are the four major types. Seriously guys, so you can remember. So if you see the dispersal, okay, right. So who is going to have the maximum connected one? Who is having the maximum connected one? By seeing this diagram only you will understand. Who is maximum connected one? The patchy, isn't it? If it is going to be patchy, it is very much connected, isn't it? Patchy is connected one, right? Yes, and metapopulation is in between. Okay, it is between, right? And then if it is going to be an island and mainland, it is not so much connected, no? It is isolated. That is why it is called as an island. So generally, if you take the road, you will not get an easy road towards an island. An island is nothing but an isolated land. But a patchy is little bit nearby. You can reach it immediately. Metapopulation is between these two. Okay, right. So dissected landscape is like it is having a cut in between. Okay, so that is quite dispersal. And how is the dispersal? This is going to be no dispersal. If it is non-equilibrium, you find no dispersal. This arrow is not there, no. This arrow is what is called as a dispersal. See, actually speaking, this land is heavily populated. Okay, it is occupied. Green color is occupied. This is the empty. If at all there is dispersal, you should have noted an arrow here, right? But here you don't see an arrow. That is why this is called as non-equilibrium. In the examination, guys, they may give you the diagram and they may ask you like match them. Okay. So if at all you don't see any arrow, there is no dispersal. No dispersal means it is a non-equilibrium. Okay. Right. And if it is going to be an island-mainland relationship, relatively the size is different. In metapopulation and all, And in your patchy also, almost all of them, they have equal, relatively like equal size. But in island mainland, one fellow will have a very big size, another one is of so small size. So this is an island and mainland thing, and this may contain an occupied patch also. This may contain an empty patch also. So this diagram, the moment you see, you may recollect it as an island mainland population. Okay. So the next one is patchy panmatic. Patchy panmatic, everybody is engaged. There is no empty patch. Okay. So everybody dispersal is there, but there is no empty patch. All of them are engaged with each other. And if it is going to be dissected landscape, it is the same one. Within the one, it is cut and it is going. Okay. So that is what is called as the dissected landscape. This is called as the dissected landscape. It is single full one. Within that, it is cut. Okay. So that is what is highly connected dissected landscape. Okay. So if I give no dispersal between them, it is a non-equilibrium. If one mainland is there and small island, it is going to be your mainland island one. Metapopulation, a combination of these. But arrows is one way. One way means it is regional or local. One way means it is going to be local, isn't it? Local is only, am I right? Check it out everybody. Local is only having one-way connection, right? But if it is a patchy, it is having between. So between it is going to be a regional scale, right? So it has a higher dispersal, no? It is helping in a better manner. Okay, so let us see the four models. Between, what are the four models? We learnt about what is going to be the what are the four models we learned? Classic Levin's model, island and mainland model. We are going to learn about the patchy and the non-equilibrium. So the first one, as I told you, it is the Levin's model, classical Levin's population. So here you have a large network with similar dynamics. They're all similar, no? You couldn't distinguish like which is bigger, which is smaller and all. Okay, and there is a higher level of interaction between the individuals within. Okay, the two words only, ma, within and between. Okay, so this is within. And all the patches are relatively small. Okay, so they have the equal properties. So extinction and recolonization is equal. Everybody is having the equal chance of extinction. Everybody can recolonize also. It is not like one is bigger, one is smaller. So that will become the source and the sink, mainland and island. But here all are equal. That is the classical Lewis one. Okay, and in classical metapopulation, so we are keeping this abundance mode. Okay, so whether it is occupied or not, like that, we are going to check. So what is going to be a patch? From the first slide, I am telling you about patch. What is this patch? This patch, it is composed of individuals as well as the metapopulation. It is going to made up of patches. So I can say that the metapopulation is made up of patches. This patch is made up of individuals. So I can say that this is going to be this one colony. Okay, so you have so many colonies, right? So now you have the apartments. Within the apartments, you have many blocks, right? Yes, so this is A block, B block, C block. So this A is going to be one patch. So what is this patch? This patch is a collection of many individuals. Within the patch, you will have several floors. Within this A block, you have several floors. Within the B block, you have several floors. That is a patch. So the total one is called as the metapopulation. So this is one apartment as such, one society as such. Then they live inside a city. Got it? So now you understood what is a metapopulation, what is an individual, and what is going to be a patch, right? Okay, very simple only, guys. Right. So the second one is going to be your island mainland model. So here the colonization is going to occur via the immigration. So from where they are immigrating? From the external source. So one source is there and then one sink will be there. Always source will be big. This is the donor. Okay, so donor is going to be very, very big and the recipient is going to be small. Right? Fine. So it is coming from the external source. Got the logic? So it is going to come from the external source. Okay, right. Yes, exactly. So that is what it is happening here. Fine. So let us see in detail about this one. Okay. So this model is going to assume that this per patch extinction and colonization rate every per means it is going to be like for every, okay, right. So for every patch, this extinction and colonization, that is not at all dependent. Okay, so if you take about this extinction and then the colonization, it is denoted by a symbol. Okay, this is pi and the p. Okay, so this both, they are not dependent upon the frequency. Very important point. They are constant. Okay, right? So what is this pi and the p? It is going to be the per patch, how many are going to get extinct. Per patch, how many it is going to colonize. It is not at all changing. Okay, so it is all going to be constant. It doesn't change. It doesn't depend upon the frequency. You can understand that this pi and the p, it is nothing but it is the per patch extinction and per patch colonization. It is a constant. It is not at all going to change at all. This is what you see in this island. Okay, right. So especially those who are appearing for this gate EY, I'll tell you this concept is very important because you will get numericals from this. Right. For those who are appearing for CSER also, please look and study these new topics, because already the CSER has asked n number of times with the known topics. So they may explore such unasked topics. Okay. So the most important patch in the landscape, it is unoccupied. Okay, and since because they are unoccupied, they are available, isn't it? So if something is unoccupied, so where the builders will buy the land? It is all going to be unoccupied. So if you see that, you take any city for instance. Okay, so generally this is going to be the city side. Already many flats have come. So will you buy in that densely populated area, or if your budget is low, what you will do? You will buy it in the outskirts. Okay. So in the outskirts, there are many lands that is available. It is unoccupied. So you will go and colonize them. Isn't it? You will go and colonize them. That is what it is happening. Okay. Yes. So the unoccupied area, it is only going to get colonized. If the most patches, it is already occupied. So take the city, it is already occupied. Then it will be very closed to colonization. Okay. So it is very closed to colonization. So it is given as I, it is equal to Pi 1 minus F. So what is going to be this Pi? Just now we saw it is telling about the rate of patch extinction and the colonization. Okay, so Pi is going to be this immigration, or no, it is the colonization. Pe, it is going to be the extinction. Okay, right. F is the frequency. It is frequency independent. If the most patches, it is occupied. So it is occupied, no? So then you cannot, you cannot occupy that area. Okay, so it will go extinct. Okay, but if it is unoccupied, yes, if it is unoccupied, then it is very close to extinction, right? So it is very close to the extinction. So it is very close to the extinction. Okay, so extinction and this unoccupied thing, it is going to be very close. Okay, right? It will go extinct, right? So it is already occupied. So you don't find a place to live there. So it is going to go extinct. Got the logic? Right? Fine. So now you are going to come up with a very important model. Okay, so you are having this homogeneous patches. So the patches, it is going to be interchangeable. Okay, so all the patches, it is going to be interchangeable and it is not going to affect anything, and then there is going to be no much time loss. Right, so this is going to be the first one. So now we have seen the first variant. So what is this variant number 1? So within that, we were just seeing about this island and this mainland. Okay, right. So we are talking about this island and this mainland. So this is a very important model. So in this island and this mainland, yeah, we saw that the colonization is going to occur. It's occurred via the immigration from an external source. So that is what is the first model that we saw. Okay, right. And then if at all it is already occupied, okay, so if it is already occupied, then it is closed to colonization. Nobody can come and occupy here. Already so many people are living in that city. So can you go and live in that city? No, no. Already everybody has bought some land or something. So the area is full. The batch is full. You cannot go inside. So it is closed. Closed means you cannot colonize there. Okay, right, fine. But if it is unoccupied, okay, so the area is unoccupied, you are welcoming people. Now will you let the people to go away from your class? No, no, you will say, see, already my class is empty, please come and sit, right? So that is what it is happening. It is unoccupied, it is closed to extension. You don't promote any extension from your class, right? Fine. So this is what is very simple understanding on this island and this mainland thing. So homogeneous means or interchangeable. It is easy and it is spatially context. It will not affect anything. So that is why I told you it is a constant. So the next one, second variant is the internal colonization. Right. So what is going to be this internal colonization? This colonization, it can happen via the immigration. Okay. So immigration from within the metapopulation itself. Internally, you are going to make a change. Okay, so from my class, you are going to my friend class. Internally, you are moving. Okay, so when few patches it is colonized, the colonization is low because of the immigrants. Okay, so this is what. So now it is going to be the immigrants, that too from the internal colonization. So they may come from internal colonization. Okay, so this is going to increase with the newly occupied patch. Okay, so it is common with the newly occupied patch. Okay, so now it is not going to make a big change. Okay, so the same organization, instead of sitting in my class, you are sitting in my friend's class. Anyhow, we both belong to the same organization. So it is not going to make a big change. Okay, so it is remaining unchanged. Okay, so that is what is important. It is internal. Okay, it is unchanged. Third one is the exam point of view. Very, very important. It is called as the rescue effect. Okay, right. So this extinction rate, you don't want it to happen. You don't want anybody to fail. You don't want anything to go away from you. So it is reduced by immigration from other patches. So if you're not understanding, somebody else is going to help you out, right? So that is what is the rescue effect. Okay, so you don't want anybody to go away. Okay, so it is going to represent the rescue effect. Okay, right. So now this extinction is approaching zero. You don't want anybody to lose. This is the perfect rescue effect. So what do you mean by rescue effect? You permanently rescue somebody. So that is what? So the extinction rate is becoming zero. Okay, you don't want anybody to fail. So that is what is the rescue. So generally whoever is very big, the donor, it is called as the source that is going to rescue the sink. Okay, source will rescue the sink. Right. Oh my God. This is done, no? Right. So the source is going to rescue the sin. Okay, fine. This is done. Yes, this is what is the rescue effect. Okay. So always you see that mainland population is very big, no? So it will not go to extinction anytime. Okay, so it is having plenty. So why it will go for extinction, isn't it? It is a source. It will never go for extinction. Next is patchy. I already told you in the first slide about the patchy. Patchy, it is all interconnected and no empty space. So no empty space only, it is the best definition for the patchy one. Okay, so there may be different models to explain this. Okay, so it is through different behavior. It may be spatially explicit model. It may be spatially implicit model, or it may be spatially realistic model. Okay, so these are the three different models based on the behavior. Okay, so now it was told based on the how it is happening. Okay, so whether it is going to extinction, whether it is going to colonize, or whether it is going to internal colonization, all the things we saw. But now we are going to see its effect on the spatial structure. So there are three basic models now. Yes. So one, it is the spatially explicit model. Two is spatially implicit model. Third one is spatially realistic model. Okay. So first let us see what is a spatially explicit model. So you assume that the local population, local means within, they interact only with the local. Okay, right. So migration, it is only distance dependent. If you are far away, this fellow will not come. No. So it is a spatially explicit model. So here distance is playing a very important role. Okay. So if it is nearby, it will go. If it is far away, no, it is not going. Okay. It is a distance dependent. This is what is called a spatially explicit model. Yes, you are in emergency. Okay, you want something near your college. Will you go and take a photocopy and come, or you will take a far away place and go and come? Definitely, whichever is near only, you are going to take and come. So that is what is going to be an explicit model. Next is going to be implicit model. Implicit model means they have an equal connection. See, this is shop A, this is shop B. Okay, this is your college or university. These both are equidistant. This has less crowd, this has more crowd. Immediately you will go to this fellow. Okay, next time you see that this fellow is having less crowd, you will go there. Okay, so it is equally connected. Okay, so it is independent of the local dynamics. It is equally connected. That is what is implicit model. Explicit model is distance dependent. Implicit model, both are equidistant. So you don't have any worry on the distance. The third one is spatially realistic model. So what do you mean by spatially realistic model? There is going to be the variation in the size of the patch. Okay, so in spatially realistic model, what happens? There is going to be the variation in the size of the patch. Okay, so in this realistic model, the patch size is going to vary. Okay, so the total patch, the number and the arrangement, it is all going to vary. So there is going to be the variation on the size, number as well as the arrangement. Okay, so they are very, very complex. So that is what is the realistic model. Okay, right. So if at all it is going to be independent, then no migration will occur. Okay, so long-term extinction rates will exceed the colonization. So this is what it happens in terms of your non-equilibrium. Non-equilibrium, there is no interaction, no. See here, in non-equilibrium, you don't have any interaction. So no interaction means obviously it is going to become extinct. You should speak out, no? You should have some interaction with your friends. If at all you stopped interacting, obviously nothing change is going to happen. Right? So you should interact with everybody, you get good knowledge. Yes? Okay. So this is having a long-term extinction because there is no dependency. It is not at all interacting. So these vacant patches are never recolonized. You see such areas in your city also, right? So few areas are abandoned, right? So they don't colonize there. So they are non-equilibrium. You don't connect with them. So they are not considered as the function of metapopulation, right? So few areas are very far away. Yes. So if it is too far away from your city, nobody likes to colonize there. But if it is somewhat near to the city, you are ready to occupy there. So that is what is about this non-equilibrium. So this divergent evolution takes place since no thing is there. Maybe if a species evolve, they may habitate there. Okay, so that is about. So questions, as I said, yes, questions have already come from the subtopic. You can't take this topic very, very lightly. It is a very important topic. So see, this is June 15 question. Okay, so June 2015, this question is asked. Okay, so let's take this question. The dynamics of any subpopulation within a metapopulation, it is differing from the normal population. What is the difference? What is the difference between a metapopulation and your normal population or a subpopulation? That is the question. So let's see the option. The birth rates are lower than the death rates. The death rates are lower than the birth rates. Immigration and emigration rates are significantly higher. Immigration and emigration rates are negligible. What is the thing that is making a metapopulation quite different from the normal population? One keyword I told you. What is that? Rescue. Rescue means there is going to be the immigration. There is going to be the emigration. This is all going to be higher within your metapopulation. Got it? Hence, this is going to be the correct answer. So, seriously, I personally feel that this topic is very, very important. So, please revise it ahead of your exam. It will be helpful for you. All the very best. I'll catch you up in another interesting session. Take care, guys.